is lesser than the velocity of light. Here we are taking two. One we are taking signal. What we are taking? Phase velocity. Vp is the velocity of what? Microwave signal which we are passing. Another we are using electron beam, which is it is represented with VE. This VE is lesser than velocity of light, whereas microwave signal, whatever we are using, VP, that is greater than C. Actually, this is velocity of light, it is greater. We have to slow down this one. For that, we are using slow wave tubes. Now, what is the second point is mentioned in this? Whatever the microwave signals we are using, the velocity is greater than the velocity of the light. We have to slow down that one. Further, here two signals are representing radio frequency signal and electron beam signal. The radio frequency signal is greater than the velocity of the light. Next, electrical signal, electron beam, whatever we want to make interaction, that is lesser than 1/10 of the velocity of light. It is 1/10 of lesser than velocity of light. These two signals I want to match. For this, I am using one hexi-lock or hexi-lock. Halos like spring shape. Actual how it is spring shape. This spring shape hexi-lock tube I am taking. One side of the tube I am sending radio frequency input. From other side I am taking radio frequency output. Actually, this radio frequency input velocity is more. After passing with hexi-lock tube, the velocity is reduced, and which it is matching with the speed of the electron beam. Speed of the electron beam. Next, where we will use this one? They are used commonly for slow wave structures. Wherever you need slow wave structure, there we will use these hexi-lock tubes with connecting wires, which are of conducting cylinder. This hexi-lock is of cylindrical shaped spring horn. Between the two what we will call at any 2 points, I am taking the distance as P. That P distance is called as pitch of the hexi-lock, and from top to bottom distance I am taking as a diameter. Like this, we have spring shape. Any one of the tip point to another tip point I am taking as a P, and from starting point to ending point. From starting point to ending point, I am calling it as a D. D is the diameter of the hexi-lock. Here I am taking at any one side of the, only one part I am considering, only to the one part I am drawing in triangular shape. In the triangular shape, here P is the pitch, another side is D is the diameter with pi. Using hypothesis theorem, Pythagoras theorem, here I am writing as P square plus pi square D square. Other side is what? P square by pi square D square. Any one turn diagram, this one. After making one turn calculation, now I am writing the velocity of the phase which we are sending radio frequency signal. That velocity is equation number 1. What is that one? Vp equal to Vc sin theta. Here theta is the pitch angle and C is called as velocity of the light. From this triangle shape, I am calculating the value of theta, sin theta. What is sin theta? P by under root of P square plus phi square D square. This sin theta is I am substituting in equation 1. What is equation 1? Vp equal to Vc sin theta. Vp equal to Vc times of what is sin theta? P by under root of P square plus D square, which is represented as equation 2. From equation 2, here this term is making 0. This term is making 0. What is written as pitch compared with the pitch angle theta? This P square value is very smaller, making it is 0. What we will get? P by under root of pi square D square. Square, this one is cancelled. We will get P by pi D. This is what is this value? This is the value of Vp. Vp equal to Vc times of P by pi D. Square under root will cancel. We will get pi D. So this equation 3 gives the velocity of the velocity of the radio frequency, whatever we are signaling inside the coil. Equation 3 gives the relation for the phase velocity along the coil in the free space. Now, I wrote for the Vp, phase velocity. What is Vp? Phase velocity. Now I am writing same thing for V. Next, what we are writing? Group velocity, Vg. Two velocities I am representing. First velocity is Vp, second velocity is G. What is G? Group velocity. What is the formula for group velocity? Group velocity Vg equal to d omega by d beta. Where Vp by Vc is calling as the delay ratio. From this Vp equal to, in general, we have one formula. What the kinetic energy formula of mv square equal to E capital V. From that, I am calculating V naught. V naught equal to what? EV by 2 EV by M, making under root. Vp equal to V naught equal to under root of 2 EV by M. I am writing. Here V naught is the velocity of the electrons, and capital V is the accelerator. How much potential it occurred is the accelerating potential. Up to here, we have this topic. Again, just we'll see overview of this, what we discussed. Overview of the topic, what we discussed. First, you have to write the introduction, why we are using traveling wave tube. This traveling wave tube is using for slowdown of the radio frequency signal, whatever we are sending. I want to interact both radio frequency signal and electron beam. Electron beam is lesser than C, whereas whatever the radio frequency signal, it is greater than C. So we have to slow down this one. To slow down this one, we are using for this X-log tube I am using. To this input side, I am entering the input. From across the output, I am collecting output. Now I want to interact this one with the electron beam. For this, we are using slow wave structures. Introduction part. Next calculation part, I am considering only one turn. Across the one turn, what is the angle of theta, and calculating sin theta value. After calculating sin theta value, we are calculating two parameters. What are the two parameters I am calculating? Phase velocity Vp and group velocity Vg. Calculating of the two velocities Vp and Vg is calculated. Calculating sin theta value and substituting in Vp, we got Vp. What is the formula of Vp? We got Vc by P by pi d. And the same way, I'm calculating group velocity. What is the group velocity here? D omega by dw. Here, after calculating the group velocity, I'm writing the kinetic energy. The energy it will be consumed of mv square equal to EV. From that, I'm taking V naught. This where V is called the accelerating potential, V naught is the velocity of the electrons. After calculating, see here in the examination, you are getting a question like previous, which what I observed, a question is like this. What is the principle of operation of traveling wave tube? Principle means this is the principle. Principle and operation of traveling wave tube means up to here you have to write. After writing this one, what is this diagram represents?
TWT structure.
Structure, how we are passing. This hexilog, this side you have radio frequency input, this side you have radio frequency output. One side you have cathode, other side we have collector. After that, for passing these electrons, we are using heater with focusing anodes. Again, using these anodes from the heater structure, the electrons is passing like this. Above the hexilog tube, we have electron beam for two magnets we have. This is one magnet and this is another magnet. These two magnets is used for slow wave the structure. And we are collecting, where we are collecting output, we are collecting output across the collector. Up to this diagram, you have to draw. For the which question you have, this question is? Essay question, what is the principle of operation of traveling wave tube? If they ask principle operation of traveling wave tube, you have to explain about these 4 slides. So in this traveling wave tube is completed, and next one which we completed last class, from this we completed 2 cavity klystron. And one is left in this. Another we can expect a question, essay question as magnetron. How we will get question regarding magnetron? Either 2 out of 3 we can guess any one question as a essay. Magnetron question, how they will ask is, explain the working of magnetron oscillator. Next topic is explain the working of magnetron oscillator. Now we will see the magnetron oscillator. Is this visible, ma'am? Next topic is magnetron oscillator.
Yes, ma'am.
Now we will see the magnetron oscillator. How you will get question? Explain the working of magnetron oscillator as a 10 marks essay question. See, this is the magnetron oscillator. This is used to also acts as a microwave oscillator. This is also called as what? microwave oscillator. In this microwave oscillator, just observe the diagram. I will draw this diagram in one whiteboard. Here in the diagram, what you have? One circle is there, and outside one big circle is there outside. Like this, one circle is there. Inside this region is called as cathode region. After this cathode region, we have resonators. How these resonators circle with gaps? This is called as resonators, and inside one is cathode, outside one is anode. This is connected like this. Resonators is connected with like cylindrical cap shaped symbols. This is called as resonators. This is called as resonators. And the top of this resonator is called as cavity. What is this one? This is called cavity. And which is cathode here, which is anode. Inside circle represents what? Cathode. What is inside circle, ma? Inside circle represents cathode. Outer circle represents anode. These are called cavities, and the space between anode and cathode is called as interaction space. What is that space?
Interaction space.
In this diagram where we have interaction space, this one, green color, whatever I am drawing, the space between which one? Anode and cathode. The space between anode and cathode is called as interaction space. Again, I am giving the description of the diagram. First one, internal part is anode or cathode. Internal part is, internally what we have? Cathode. Outer part we have anode with cavity resonators. What we have? With cavity resonators. The gap between the anode and cathode is called as interaction space. Each resonator is of 180 degrees phase angle. What is the phase angle of between each resonator? Each resonator is of 180 degrees phase angle, and we are applying DC voltage as well as magnetic field. I am applying both DC voltage as well as magnetic field. Where I am applying DC voltage and where I am applying magnetic field. What is the outer part? Outer part is anode. To anode, I am applying what? DC voltage, and magnetic field is also applied. By applying magnetic field and both, what happens? Some path is produced in between anode and cathode. Here like we have inside cathode, inside anode. By applying DC voltage as well as magnetic field, some path is produced in this what is this region is called? Interaction space. Some path is produced in the interaction space. This path I am calling as cycloidal path. What is the name of the path? Cycloidal.
Cycloidal path.
The path whatever we are getting is called as cycloidal path. This cycloidal path we are getting because of the what? Electric field as well as magnetic field. Electric field is producing by DC. Also we are applying another field. What is another field? Another field is called as magnetic field. And each resonator cavity having 180 degrees out of phase. Now we will see just book a PDF checking just a minute. In this, now which one we are seeing now? We are checking for the magnetron. What is the introduction is given in this? We will check both the written part as well as textbook format. See here, what is why we will use this magnetron? Magnetron is used for what? Microwave, high power microwave. Magnetron is used for high power oscillators. What are the components? So this first paragraph in the textbook is given the description of the diagram. It contains both, what are the two contents? It contains both cathode and anode with resonant cavities. Here, which are resonant cavities? These cylindrical circular shape. These are called resonator cavities. The basic structure of cylindrical cavity consists of anode with a number of resonators. Is outside part is anode or cathode? Outside part is anode. Inside part is cathode. Outside part is anode with number of resonators. And the gap between the anode and cathode is called as what? Interaction space. Here, permanent magnet are used to produce the magnetic field. Whatever the magnetic field we are producing, it is in perpendicular direction with the tube. A high DC voltage, where we are applying DC voltage? DC voltage is applied across the anode. DC voltage is applied across the anode. And we have N-coupled resonators. In this diagram, how many resonators we have? 1, 2, 3, 4, 5, 6, 7, 8. Whatever the diagram we are observing, it is 8 coupled resonators. This is 1. This one is 2. This one is 3rd resonator. This is 4th resonator. This is 5th one. Next 6th resonator. Next one is 7th resonator. Next one is 8th resonator. Like our diagram is 8 coupled resonator. For the other, like this, instead of 8, we can also use N coupled resonators. Each resonator having a pi mode oscillator, which it is pi mode, means pi means 180 degrees, means the phase angle between each resonator is how much? 180 degrees. You have to write about the description of the diagram. After writing description of the diagram, where we are applying DC voltage is applied to the magnetic field. After applying DC voltage and magnetic field, what is producing? A cycloid path is producing between anode and cathode. And now here in this diagram, what is this diagram represents? Suppose before applying magnetic field, only electric field is applied. Only electric field is applied. The electron is moving from like this straight direction without applying magnetic field. Without applying magnetic field means B equal to 0. If B equal to 0, the electron is moves in this direction. Suppose I am applying some magnetic field at some particular point. That particular point is called as critical point, BC. The magnetic field across the critical path. What is it means? BC. If some path, what happens? Before applying magnetic field, it is moving straight. After applying magnetic field, it is like this, it is going. If the critical path, suppose I'm applying magnetic field some value. I'm setting my value as critical value. Suppose if magnetic field is equal to the critical value, at that time what happens? Without magnetic field, it is going straight line. If it is greater, it is touching the anode. If both are equal means it is going in circular path and again touching to the cathode. Next, if B is greater than BC, means this way it is going and it is coming to its original path. It is coming to its original path. So this diagram represents without magnetic field. If we are applying magnetic field, what happens? Before magnetic field, it is moving straightly. If we are applying magnetic field, in this diagram, same thing is there in this diagram. Yeah, I missed in this diagram. The shapes are missed in this, no problem. Without applying and with applying. Without applying, moving straight line. Suppose small amount is magnetic field applied. It is started. Movement is started. If both are equal, it is going into the circular path. If more greater means it is traveling for shorter distance and reached again to the cathode region. So Up to this point, you have to write for the question. What is the question? Explain the working principle of magnetron oscillator. Means first principle you have to write, and also you have to calculate this two voltage, cutoff voltage as well as hull cutoff magnetic field and magnetic voltage. We will see these two derivation part. Operation is over. Now we are seeing derivation part. For derivation part, first I am using force. What is F equal to ma in terms of voltage and in terms of electric field and magnetic field. This equation in terms of electric field and magnetic field. In terms of electric field and magnetic field, what is the equation we have? F equal to, what is the equation? F equal to E times of electric field E plus V into B, where B is the magnetic field applied, E is the electric field, E is charge of the electron, V is the velocity. From this one, F equal to ma. This A is written in terms of dV by dt equal to minus E times of E plus VB. And M is shifted downwards. If M is shifted downwards, what we are getting equation? dV by dt equal to minus E by M, E plus V into B. E plus V into B. Next, I am writing three polar coordinates. So this is this magnetron is working in cylindrical coordinates. In cylindrical coordinates, I am using three terms R, phi, Z. Using these three terms, in the first unit is there. In that, we have these three equations. In the first unit, again, I will cover in offline classes, this derivation part is covered. Again, we will see those three equations, how we got in online part in the first unit. What are the three equations we have? Cylindrical coordination system in terms of electric field and magnetic field. For examination, you have to learn these three equations. The next derivation is completely depends upon these three equations. What is the first equation? D square R by dt square minus R times of d phi by dt whole square equal to minus E by M. Elect ER, R, Z, phi. First equation is in combination of R, Z, phi. Second equation you just observe. It is in the combination of pi. First is pi. Next is Z. Next one is R. Next third one is in the combination of Z. Third one is in combination of Z. Next, what you have? Pi. Next is R. These three equations you have to learn. The same three equations is given again in the here. What are the three equations? D square R by dt square minus R times of d pi by dt whole square equal to minus E by M terms of Ez BZR d phi by dt minus B phi times of dz by dt. This is second equation. Next, another equation is 1 by R d by dt R square of d phi by dt equal to minus E by M E phi plus BR dz by dt minus BZ dr by dt. Like this, we have three equations. And one more formula we have. What is a cyclotron frequency? Another formula we have omega c equal to small e by capital M times of B is the magnetic field. Across here, I am calculating across some Z axis, magnetic field along Z axis is what? BZ. Now, here I am taking two radiuses x and y. What is x radius and what is y radius? X radius and y radius. Inside what we have? Cathode. Outer side what we have? Anode. Center point to the cathode is x. Center point to the cathode is x. Center point to the anode is y. And these, so before going to the derivation, we have to remember these four equations. 11.2, 11.3, 11.4, 11.5. Using these, now we will see the derivation part. Omega c equal to E by M times of B, and we are taking two radius. X is the radius of the cathode, Y is the radius of the anode. Next, what is BZ? BZ is the magnetic field. Now, from second equation, I am simplifying this one. What is the second equation we have? In this what is second equation here? 1 by R d by dt R square d phi by dt is equal to, I am considering, I am making this term 0 and this term 0, only concentrating on this term. So now I am writing equation. From equation 3, I am writing 1 by r d by dt times of r square d phi by dt equal to minus e by m. In place of r along z direction, I am taking bz times of dz by dt, which is mentioned here. See here. So only one term I am taking and I am making other two terms as 0. From equation 3, I wrote this equation. From where? Equation 3. What is equation 3 here? Equation 3 is 1 by r d by dt r square d phi by dt, written as it is. Again, after that, r is cross multiplied actually. This side, which one we are taking? RHS side. RHS side, I am taking br dz by dt. Here, see, br dz by dt. In place of r, I am taking along z axis bz. This 1 by r of LHS is cross multiplied.
R is going to RHS, ma'am, right hand side. We are taking R at right hand side.
7. After substituting in 18.7, what equation 7 becomes? As it is d by dt. This equation now you cross it. D by dt, r square d phi by dt is as it is. E bz by m. This term is here. Next, what is in place of r dr by dt? I wrote 1 by 2 times. This is 2. 1 by 2 times of d by dt of r square. Just r dr by dt is replaced with 1 by 2 times of d by dt of r square. And next, we have equation 5. What is equation 5? Previously we discussed, I said to remember 4 equations. In that,
Omega C equals to E by M into B.
EB by m. In place of EB by m, substitute omega c. Here, in place of EB by m, substitute which one we have to substitute? Omega c. 1 by 2. This 1 by 2 is written here. 1 by 2. In place of EBZ by m, I wrote omega c. Next to d by dt of r square. This is equation number 9. Now integrating equation 9, this d by dt will be removed after integrating. So what we will get after integration? R square d phi by dt is equal to 1 by t omega c. Different integration means this will go r square with some constant k, where k is called as a constant. In equation 10, I'm imagine r as a x and I'm keeping d phi by dt equal to 0. At that time, what happens? This LHS term is completely 0. If LHS term is completely 0, what we will get? K equal to minus 1 by 2 omega c r square. In place of r, I'm substituting x, this one. In place of k, in place of r, substitute x. In place of r, substitute x. In place of r, substitute x. In place of d phi by dt, keep 0. This whole term becomes 0 and we have only RHS term. In this RHS term, what is the value of 1 by 2 omega c? In place of r, I am writing x square equal to minus k, which is given in the down step. We got k value. Now what I am doing? This k is again substituted in the 10th equation. This k is again substituted where? In the 10th equation. And we will cross check what happens. This k is representing with equation b. Equation b is substituted in the 10th equation. So what we will get? R square d phi by dt 1 by 2 omega c r square. In place of k, I am substituting minus 1 by 2 omega c x square is substituted. After substitution, this r square is moved to the right hand side and keeping only d phi by dt term. D phi by dt equal to 1 by t omega c minus, after making this, we will get this equation. What is this equation? This equal to, we got d phi by dt. Now what I am doing? In place of r, I am keeping y. 2 radiuses. X and Y. X is internal radius, Y is outside radius. In the energy released of mv square, we know this equation of mv square equal to EV. From this, I am writing V square equal to 2 EV by M. 1 minute, small fraction, I think. Here, this is small v, ma. Or else both the v's will be cancelled. I wrote wrong here. No problem. Of mv small v square equal to small e times of capital V. From that, I am writing small v square. Small v square is equals to 2e capital V by M. Here, we wrote 2e capital E by M. Next, this 2e capital VM is both radial part and phi. It is a combination of both r and phi. From that, I am writing velocity of radial velocity, phase angle velocity, phi, angle phi velocity. VR is represented with dr by dt. V phi is represented with r times of d phi by dt whole square. Again, I am taking r equal to z, r equal to y, v equal to v naught, dr by dt in this equation. In equation number 12, I am placing dr by dt equal to 0. If dr by dt equals 0 means this term will be 0. So what we have? R times of d phi by dt whole square. In place of r, I am keeping y. In place of what I am keeping? Y. Y times of d phi, that is down step, I think. This one here. This here. 2e in place of v, I am substituting v naught. In place of v, I substituted v naught. 2e v naught by m equal to dr by dt equal to 0. If dr by dt equal to 0, what we will get? R times of d phi by dt whole square. In place of r, substitute y. R square means y square times of d phi by dt whole square. Now d phi by dt is equal to 1 by 2 omega c 1 minus x square by y square. From where we got this equation? Equation number 11. What is equation number 11? This one. In this place, I am substituting in place of r, what I am substituting? Y. D phi by dt equal to 1 by 2 omega c 1 minus x square minus y square. That one is substituted. Just refer your textbook. Keep your textbook in front of you. Then you will understand whatever I am covering. Here, I substituted both.
Ma'am, please once repeat the how equation 12 we got.
Okay, ma'am. Equation 12. These actually here from the diagram, radial velocity as well as phase phi. The distances is represented in cylindrical format. In place of direct step we are writing. I am not deriving here from previous equation. From previous part, I didn't wrote this one. From the cylindrical coordinates, velocity of radial part is also can be written as dr by dt. Okay. This VR is there na? In place of VR, I am writing dr by dt whole square. In our textbook, this VR square plus V phi square is not mentioned. In the textbook, you just observe from 11.11 to directly 11.12 is given. But how we got this one? This 11.12 or 12th equation, we are getting dr by dt whole square from the velocity of the radial part. What is the velocity of the radial part? Dr by dt. Next, velocity of this radical part, another pi component. Velocity of the pi component we are getting can be also be written as r times of d phi by dt. Okay, ma, is it?
Okay, ma'am. Okay, ma'am.
So in this, what I am doing? Dr by dt, you keep 0. If you keep dr by dt, this component is completely vanished. Is it? And keep
Yes,
r
ma'am.
equal to y. If r equal to y, what you will get? Y square times of d pi by dt. Is it? In place of what I have to write? Y. Then what we will get? Y square times of what I will get? d square by
Pi square by dt square.
dt. This one I am getting RHS side. Across LHS side, in place of V, substitute V naught. In place of V, what I have to substitute? V naught.
V
In
naught.
place of V, if you substitute V naught, you will get equation. Which equation you will get? You will get equation number, this one. Here I did mention, number is not mentioned. This one we will get. Okay, ma? From 12, I got this part. From 11, I am getting 13. What is 11th equation? From 12th, I am getting this part. Imagine that this as C or D. Some equation, if I change in the middle, imagine this as D. And now how we got 13th equation? 13th equation we are getting from 11th equation. What is 11th equation? d phi by dt 1 by t omega c. In place of r, I am substituting y. d phi by dt equal to 1 by 2 omega c times of 1 minus x square by y square. 1 minus x square by y square. We got 13th equation and 14th equation. Next, what I am doing, substitute 13 in 14. What is this 13? 13 is d phi by dt. We have to substitute in the equation number 14. And we will see what we will get. What is 14th equation? 2e v naught by m. LHS is as it is. Y square is as it is. In place of d phi by dt, I am substituting 1 by 2 omega c times of 1 minus x square y square. We have d phi by dt whole square. For that, this square is copied as it is to down part. We got equation number 15. From 15th equation, next what we are calculating? Original value. What is omega c we kept?
EB by m.
Previous. From 5th equation, substitute your original omega c value. Omega c value equal to EB at across critical EBC by m times of 1 minus x square by y square whole square. We got this one. Now what I am doing, I am calculating BC. What I am calculating from this? I am calculating BC. This BC derivation is called as what? Hall cutoff magnetic field. If you calculate BC, that is called as what, ma? Hall cutoff magnetic field. From the same 16th equation, if I calculate V naught, what we will get? Hall cutoff voltage. Voltage. So final equations, two equations we had to write. What are the two equations we had to write? In terms of voltage, one equation. In terms of
And
magnetic
magnetic
field, one
field.
equation. Now we will see in terms of magnetic field equation first. Then we will come to in terms of voltage equation. And now you observe 16 and how I am deriving equation number 17. Your task, how I am deriving. You just cross check it.
Only cross multiplication.
Cross multiplication and keeping BC term at one side, remaining terms at other side. And BC square we got, and I am writing in terms of BC. Now we will see one by one step. BC square, 4mv square is in the denominator. This is shifted towards this one. What it will be? 8 EV naught m square. This m square is also going towards this. By this original m we have.
Yes,
Original m we have. And next what? BC square is as it is. This E square is in numerator, that is came to denominator. This whole term is in the numerator, that term is different, shifted to denominator. After shifting the denominator, the small adjustment of, we will get the value of BC. Again, from the equation 16, we have to derive the value of voltage VE. If you write this complete answer, your magnetron answer will be completed. What is our topic, ma?
Magnetron.
Magnetron. Again, we will recall once again what we discussed in this magnetron. What is magnetron? Where we will use this one? We will use this one for microwave oscillators. In microwave ovens also, inside we have this magnetron. This is inside what we have here, cathode. Outer part is anode. The space between cathode and anode is called as interaction space. We have cavities, resonator cavities. Each cavity of 180 degrees phase angle between each cavity. And we are applying DC voltage to the anode or cathode. Outer part is
Anode.
anode. I am applying DC voltage to the anode, and I am also applying magnetic field. By applying magnetic field as well as DC voltage, some cycloidal paths. What is this path, man? Here you have dots in the textbook. What is this path?
Cycloidal paths.
Some cycloidal paths is produced in this, and we are checking for before applying magnetic field, how the diagram, after applying magnetic field, how the diagram. If the magnetic field is more, if the magnetic field is less, those four symbols also have to include in this notes. I missed. What is before applying magnetic field? It is traveling in straight direction. Is
Straight
it?
line.
Which
Yes,
is in the
ma'am.
textbook. Suppose if B is greater than BC, complete
Downward.
trajectory, completely coming towards this one. Suppose both are equal,
It
it
will
is coming to the original path, traveling and coming to the original path. If B is greater than BC,
it follows a shorter path.
it is traveling in the shorter path. This one you have to write. Next, you have to calculate it, two voltages. What are the two voltages we calculated? We calculated HC and VC. What is HC and what is VC? What
Hall
is
cut
HC and
off
what is
volt.
VC now? HC is Hall cutoff voltage. What is VC?
Hall cutoff magnetic field.
Hall cutoff
Magnetic flux density.
magnetic resistance. So we completed which one? Microwave tubes block 5 is completed. In this two cavity klystron, few more topics is there. We will see those topics. Essay type questions is covered. Essay type questions is principle and working of klystron, and principle and working of magnetron, and principle and working of traveling wave tubes. 10 marks question is covered. Now we will see the short questions in two cavity klystron. Whatever we have in two cavity klystron, we will see that one. Please, next, what is the function of two cavity klystron? First, after discussing this, we will calculate the modulated velocity, we will calculate the bunching process, and we will go for the efficiency. We completed this in the yesterday's class, is it?
Yes, ma'am.
What is two cavity klystron? Your task, anyone respond. What is two cavity klystron? It's functioning. What is this block? What is this one? Here,
Modulation of velocity.
very good. Velocity is modulating. From where to where? From cathode to the collector.
Collector.
Is modulating from cathode to the collector.
Collector.
Collector. Here, what are the components we have in this? Just to overview what we discussed yesterday, because the next topic is the continuation of this one. Today, next two topics which I am covering today is the expression for velocity modulation. We will see. Next, we will see bunching process. Next, we will see another one, output power and efficiency. We will cover now these three short answer questions one by one. Before these three are linked with two cavity klystron. In two cavity klystron, what we discussed yesterday, it having one cathode,
Buncher cavity,
heater,
capture cavity, collector.
Collector, RF input, RF output, drift space.
Drift space,
Heater
cavity,
producing electron beams.
Beam.
Very good. And these two bunches are in cylindrically shaped, is it?
Yes,
cylindrical shaped bunches. What is there in the first paragraph we discussed? In the first paragraph, what we have? The catcher cavity is located. The catcher cavity is towards where? Cathode. The catcher cavity is towards collector.
Yes.
Next, buncher cavity is towards the cathode. The gap between these two is called as what?
Drift space.
Drift space. And we are passing electrons from where? Heater. We are passing electrons from the heater. And the electron beam contains AC component. This AC component is producing current. As voltage is increasing, EMF is produced, is it?
Yes, ma'am.
After this slide, after this, we will come to this one. Next, in this. This is what we are discussing in this. We are applying positive cycle as well as negative cycle. If I apply positive cycle, velocity is increasing. For negative cycle, velocity is decreasing. Across the drift region, what is the velocity? Unchanged velocity. Velocity is 0. Across where? Drift space
Voltage
region.
0.
Voltage is 0. From that, we are writing expression VI equal to Vs sin omega t. From there, here I'm saying as a positive off cycle. Next, what we have? Negative off cycle.
Negative half cycle.
In positive half cycle, velocity is maximum. In negative half cycle, velocity is minimum. Across this point, what is the velocity? Velocity is 0. It is producing some current. If current increases, what happens to the density? What happens to the
Density increases.
Density
Density
increases,
increases.
EMF decreases.
EMF is decreased. That is explained in this paragraph. Next.
Acceleration of electrons and deceleration.
Deacceleration of electrons. Acceleration of electrons is lesser. Deacceleration of electrons is more. Which that one is explained in this last paragraph. Current produces an induced EMF which produces opposing of the current. If density increases, what happens? If density increases,
EMF
current is
decreases.
increasing,
EMF
is
decreases, which will deaccelerate the electrons.
Very good. If EMF is decreasing, it is deaccelerating the electrons. Suppose density is decreasing, EMF is increased, which it accelerating the electrons. However, the electrons will be deaccelerated and only few are accelerating. So accelerating of electrons is lesser compared to maximum number of electrons are deaccelerating than accelerating. So up to here, you have to write two-way cavity klystron. And next topic we have is, yesterday already we discussed this one. Next topic we will see is expression for velocity of modulation. This expression for velocity of modulation, we will see here. What is this diagram? Two cavities, bunching cavity and another cavity is what?
Catcher cavity.
Catcher cavity. The space between these two is any one. From starting entry point to the exit point, here entry point, whenever the electrons beams are touching this cavity, this electrons beams are touching here. This touching point I am taking as a T1 and leaving point from where it is leaving, that point I am taking is what? T2. Two time periods, entering and exiting periods. Entry period is taken as T1 and exit period is taken as T2. The difference between these two, the space between inside the cavity, I am treating as D. Again, two time periods T3, T4 and the space is D. What is here? Here we are applying input microwave signal. Here I am taking amplified current outside. What is this one? This is electron beam. Here V is anode potential. V of E is the velocity of the electrons entering inside with the time period. From this, I am calculating V of E. What is V of E? 2EV by M. This from where we are getting of mv square is equals to EV. Kinetic energy of mv square equal to EV. From this is velocity of the electron, VE. From this, I am writing the value of VE of mv square equal to EV. From VE, I am getting under root of 2EV by M. Where is the charge of the electron? Here, whatever the input signal I am applying, that one I am considering as Vs. What is Vs? Vs is microwave signal applied to the cavity. And from microwave signal, I am writing one equation. What is the equation I am here considering? Vs equal to Vs beta sine omega t, or Vs equal to Vs sine omega t here. This here is this V small v, this is capital V. Capital Vs equal to small Vs sine omega t, and this capital, 1 minute, it's cross.
Small vs is equal to capital Vs
Yes,
sin omega t.
small v equals to capital V.
Which is capital and which is small here?
Left side small and right side capital.
Left side is small. Right side is. This is capital or small?
Is small.
Small.
Small vs. Small vs equal to here
Capital
Capital.
Vs sin omega
capital
t.
Vs. While taking this, just make a small correction in this. Capital V equal to small Vs sin omega t. Vs is lesser than capital V. And here we are taking transit time, entering and exit time. What is entering and exit time? Capital T equal to T2 minus T1. From where we are getting this T2 minus T1? From the diagram. Entry time is T1. Exit time is T2.
Leaving minus entering.
This is called as transit time. T2 minus T1, where D is the distance. From this, I am writing angle, transit angle, theta. What is theta formula? Omega times of T2 minus T1. Omega times of T2 minus T1. This T2 minus T1 can also be represented as what? D by VE, velocity of the electron, VE, small v. Velocity of the electron, VE. Next, we are substituting this across where? First equation. Now, what is our first equation? Just now we discussed what is Vs? What is capital? Here small Vs equal to capital V equal to Vs times of sin omega t. In this place, I am substituting this one. Vs equal to Vs times of beta sin omega theta t plus 1 here. This is not substituted one actually. The previous 2 time periods. This is general equation, not the substituted one. We are writing this equation directly only. This is direct equation only, not substituted part. Here Vs beta sin omega t plus theta t by t. Here we are considering beta as what is the formula of beta? Beta equal to sin theta t by 2 by theta t by 2, where beta is called as coupling coefficient. Next, here energy equation. Energy equation. What we have energy equation of mv square equal to E capital V. Actually, what is kinetic energy formula of mv square is across LHS is E times of capital V. In place of capital V, I am writing V plus signal voltage Vs. In place of capital V, I am writing V plus Vs. From this, I am calculating Vt. Vt means M will grow to that side and root, we will get this one. 2E by M under root of V plus Vs. Now,
మేడం పేజీ కంప్లీట్ కనిపించట్లేదు మేడం స్క్రీన్ పైన.
ఓకే, చెక్ చేస్తా. వస్తుందమ్మా? వస్తుందమ్మా?
వస్తుంది మేడం ఇప్పుడు.
ఓకే, ఒక నిమిషం మళ్ళీ ఇక్కడ నుంచి స్టార్ట్ చేస్తాను. వాట్ ఈస్ V? V is the anode potential. V is the velocity of the electron. Of mv square equal to E capital V. From here, I am writing velocity of the electron VE. Next, I am writing input signal. Whatever the input signal we are using, I am taking that as Vs. So we have formula capital V equal to Vs times of sin omega t. And taking time period t equal to T2 minus T1. From there, I wrote Tt value. Here, signal, average signal of the buncher gap, signal equation I am writing. From signal equation, this is what? Vs equation. Next, I am taking energy equation. What is energy equation of mv square equal to EV? Actual, what is the formula of mv square equal to E capital V? In place of capital V, I am substituting V plus Vs. From this, I am writing Vt value. What is the value of Vt? Vt equal to this cross multiplication 2E by M. As I am removing square, we will get under root. Under root 2E by M, under root of V plus Vs. Under root of 2E by M, This Vs is, I am substituting from which equation number? Vs equation number is what here? This. Equation number 4. Vs equal to Vs beta sine omega t plus theta 2 by 2 is substituting here. This one and K. This one. And here I am making common capital V. If I make capital V common, here no V, so I wrote in the denominator beta Vs by capital V sine times sine of omega t plus theta t by 2. Here beta t, beta Vs by V is called as depth of the velocity modulation. How much inside depth we have? From this, again what is called depth of the modulation. Next Vt equal to beta Vs by 2 Vr. Something is wasted. It's just I will cross check. Depth. Next from 2 EV by EV not times of what is here EV?
We are putting
What
2EV by
VE
M equals
equation.
to VE.
What is VE? What is in the beginning we wrote VE. What is VE? Ma? In the beginning, what is VE?
2EV by M.
VE equal to under root of 2 EV
2EV
by
by
M.
M.
Just
2EV
that one
by
is
M.
substituted here. 2 E by M is substituted here. That one I am writing as what? VE.
VE.
Okay. VE 1 plus beta Vs by here binomial expression. So in velocity I am taking as 2 times of the radial velocity. Total velocity I am taking as 2 times of the radial velocity plus sine.
Ma'am, we are continuously putting the taking under root now. From equation 7 to next equation. Root. Ma'am, you are on mute.
This plus symbol represents a modulated voltage across entry point. 2 time periods we have. Did you remember across the entry point we have T1 and T2? Across the exit point we have time periods T3 and T4. These two. So maximum velocity and minimum velocity. The maximum velocity we will get formula plus. For the minimum velocity we will get formula minus. So this is the topic for which topic we discussed. This is the topic of modulated wave velocity. We will see once again from the beginning, just overview of the topic, what we discussed.
Ma'am, in the textbook, they're given V1. You said that as VT. V1 or VT, ma'am?
In textbook, what it is mentioned, that is VT.
V1.
That is a time period T, that is.
Yes, ma'am. Energy at the time, na? So VT.
That is T.
Huh.
What we discussed here, velocity of the electron formula is written. Next, signal voltage equation is written, V equal to Vs sine omega t. The same equation written in terms of theta, which is equation number 4. From equation number 4, I am concentrating on beta. What is beta? Sine theta 2 by 2 by theta by 2. This is called as coupling coefficient. After that, in general, kinetic energy of mv square equal to E capital V. In terms of V, I am substituting V plus Vs. And I am substituting the equation of Vs in this. After substituting the equation of Vs, Just keeping capital V common, what we will get? 2e capital V by m times of bracket 1 plus beta Vs by capital V sin omega T1 plus theta T by 2. Up to here is completed. Next, in place of 2eV by m, I am writing velocity of the electron VE, and in place of capital V, I am taking radial velocity 2 times of VR. We will get the final equation.
Ma'am, there is a root in the equation 7. After that, how the root is reduced, ma'am?
No, root is there.
2e.
Root is there. 1 minute, 1 minute. I will cross check.
No, ma'am. In textbook also root is reduced.
In textbook also there is no root, ma'am.
Root,
For that, once check in the textbook also, ma'am.
V common 1 plus beta Vs by V term.
And also from equation 7 to 8 in the textbook, Vt is rewrite as a Vt square, I think Vt2. Once check, ma'am.
That is time period T2, ma. Just check the diagram, entry point and exit point. Entry point is T1.
T2 is leaving point.
T2. Why I will cross it.
Excuse me, ma'am, eighth equation.
Eighth equation.
Last లో theta నా లేకపోతే del T నా మేడం అది?
That's theta. That's theta.
Theta T అది. Theta T అమ్మా అది. Theta T. Subscript T. Theta times of T. I will cross check this once again and I will inform you, ma, about the equation 8. In direct, in place of VE under root of 2 EVM by come. VE is okay, root is gone here. Okay. See here, this is a binomial theorem. From binomial theorem, the root is vanished here. As expanding the term. In the textbook, you just observe using binomial theorem, one term is mentioned. In the above, you have root. In the above, you have root here. See, ఒక్క నిమిషం అమ్మ ఎరేస్ చేసి చూపిస్తాను డిఫరెన్స్.
అంటే ఇది రూట్ ఎలా వచ్చిందని డౌట్ అంటున్నారా ఎట్లా మేడం?
ఎట్లా ఒక్క నిమిషం చెప్తానమ్మా.
ఇక్కడ హాఫ్ ఎంవి స్క్వేర్ తీసుకున్నాం మేడం మనము.
మీ డౌట్ చెప్తాను, జస్ట్ మినిట్.
ఓకే ఓకే, నాకు అది అర్థమైంది మేడం, అందుకే అంటున్నాను.
అదే టు అదర్స్ ఐ విల్
స్క్వేర్ ని మనం అటు సైడ్ పంపించేసినాం కాబట్టి అక్కడ రూట్ వచ్చేసేసింది.
అంతే. ఇప్పుడు ఇది యాక్చువల్లీ
ఆఫ్టర్ దట్ మ్యామ్ ఫస్ట్ స్క్వేర్ ఈజ్
చెప్తున్నానమ్మా. ఇగో ఇందులో చిన్న లైన్ మిస్ అయింది. ఇక్కడ దీనికి రూట్ ఉంటుంది, ఇక్కడ దీనికి రూట్ ఉంటుంది. ఓకే, ఇక్కడ బిఈ ఉందా, ఇక్కడ ఇది రూట్ పెట్టండి. పెట్టామా? Here you have root. In binomial expansion, only first term is considered. In that way, we are removing root here from the first term to the second term. Ikkada rasa children binomial theorem from 7.7 expanding this one using binomial theorem, the root is removed.
Okay.
After removing root, we are writing in terms of plus and minus. After root removed, we wrote this one in terms of plus and minus. A final equation, we are writing V maximum and V minimum. This V maximum, V minimum represents velocity modulation of the two cavity klystron. Is this okay, ma, this topic?
Okay, ma'am.
This can be treated as a short answer question. Next, we will see efficiency topic. Next, we will see output power and efficiency. Next, we will go for bunching process. It's a lengthy one. First, we will cover efficiency one. Here, for this two cavity klystron, we have to calculate both power as well as efficiency. Smaller topic. I think this one is gave for your assignment question. Is it? Assignment
No,
or
ma'am.
yes or no?
No, ma'am.
efficiency
No,
is
ma'am.
from
No, ma'am.
antenna.
Antenna of efficiency. Okay.
Yes, ma'am. Efficiency.
Here, this is output. This efficiency is different, and that one, this efficiency is related to klystron.
Yes, ma'am.
Here, see here, output power. Directly, we have power formula. Power equal to P output power. P naught. Naught represents output. Power P is power. 0 is output. Power P naught. Output power equal. What is the formula? Beta times I naught V2 and Bessel's function. Did you remember Bessel's function in mathematical equation? We have J. Bessel function is represented in terms of J. J1 times of X of cos phi. This is the Bessel function. Using Bessel function, we are writing output power P naught. In this, what is beta? Beta is called as coupling coefficient. I naught is called as current. V2 is the voltage between anode and cathode. X is called as bunching parameter of the klystron. Pi is applying to the 0 degrees. This is topic I wrote a little bit different from the textbook. You copy this one, I will send PPT. Here P naught is, what is the formula of P naught? P naught equal to beta I naught V2 J1 of X. Beta is coupling coefficient, I naught is the current, V2 is the voltage between the anode and cathode, J1 of X, this represents a Bessel's function where X represents the bunching parameter of the klystron. And here I am taking cos phi. Phi I am taking as a 0 degrees. Using this one, I am writing next equation. Here cos phi I am taking as a 1 and I am substituting directly the value of Bessel function J1 of X. I am writing as X value I am taking as 1. This is some fixed constant value. Don't change this value. What is this 1.841 represents? This is fixed value. And in the equation, I am substituting beta equal to 1. What is the value of beta? Beta equal to 1. And substitute in the above equation. This is equation number. Imagine this is equation number 1. Substitute in equation number 1. What we will get in place of beta, I am substituting 1. I naught is written as it is.
Yes.
I naught is written as it is. And V2 is also written as it is. In terms of J1 of, what is in place of X? What I have to substitute?
1.841.
1.841 cos phi equal to 1. After that, we will get Bessel function value J of 1.841 equal to, if you press even in the calculator, we will get what is Bessel function of 1.841? We will get 0.582 times of I naught. Next, V2. What is 0.582? This represents the efficiency power, how much it is producing. What is P naught maximum? This P naught maximum is across catcher cavity. Maximum power is catcher cavity is across input side or output side?
Maximum outside.
Outside. So we are calculating power across the output side. So output power, what is the formula for output power? Output power P naught maximum equal to 0.582 times of I naught times of V2. Next, we will see the efficiency. Efficiency is AC power by DC power. What is the formula of efficiency? AC power by DC power. AC power, same equation, whatever I wrote power equation, again I am writing here. What is power equation? Beta I naught V2 J1x cos phi. Cos phi equal to 1, beta equal to 1. And substituting here, beta, if we substitute 1, I naught V2 J1 of X by DC power. P equal to IV formula I naught P naught. This I naught will be cancelled. What we got? Beta as it is. Next V2. Next J1 of X by V naught. By V naught we got. Efficiency is maximum. Substituting, what is the value of X? We are substituting the value of X equal to 1.841. Beta V2 J1 of 1.841 by V naught. What is J1 of 1.841? J1 of 1.841 equal to 0.582 times of beta V2 by V naught. From this, I am calling as 58% efficiency. Why I am taking 58% of efficiency? In this equation, I am treating beta equal to 1. What is the value of beta? Beta 1. and I am treating V0 equal to V2. Then both will cancel. V0 will cancel. Beta equal to 1. Then we will get efficiency eta equal to how much? 0.58% or 85.2% efficiency we have using klystron. 2-cavity klystron. What is the efficiency we are getting? We are getting efficiency as 58%. Next, we will see one more topic. What is the topic is bunching process. Where we will get this bunching, ma?
From the heat to electron beam and
In the drift space, I think.
In the drift space region. This bunching is across drift space region. Now we will calculate the bunching process. Same continuation of two-way klystron. We will see this one. Continuation of two-way klystron we will get. Here, what is the velocity, ma?
Excuse me.
Here we have positive. What, ma?
Maximum
ఇక్కడ
velocity.
అవుట్పుట్ ఎఫిషియన్సీలో అన్ని ఇక్కడ మనము Vmax Vmin అని తీసుకున్నాం కదా మేడం. ఇక్కడ Imax అయి ఉన్నది మేడం టెక్స్ట్ బుక్ లో.
టెక్స్ట్ బుక్ ఏది మా అవుట్పుట్ పవర్ అండ్ ఎఫిషియన్సీ?
అవును మేడం. అక్కడ కూడా మళ్ళీ 2I0 ఇంటూ 0.5I2 వచ్చింది కదా మనకి. Imax అని తీసుకున్నాం. ఇక్కడ మనం ఏం Vmax.
అవును అవును మా.
ఇక్కడ మన ఇంటూ 2 ఉంది కదా మేడం. 2I0 ఇంటూ 0.582 అని.
అవును. I didn't wrote this from textbook. Whatever I given, you copy this one. This is more clear compared to that one, ma.
అంటే మనము V లో తీసుకోవాలా I లో తీసుకోవాలా మనం ఇంతకి?
ఇప్పుడు నీ డౌట్ ఎక్కడ?
మనం Pmax అని తీసుకుంటున్నాం.
Okay, we wrote equation in terms of power, directly wrote, not in terms of I and V. ఇక్కడ మనం in terms of power I wrote, just cross check.
Yes, ma'am.
We wrote directly in terms of power equations I wrote. In the textbook, the equations is in terms of current.
Current and
Voltage. So don't see here in this separate in the textbook. Bessel functions related two equations is given with two constants, an equal to 2I0. I will show that one. So easy to remember notes I wrote instead of by hearting those equations.
Okay.
Ma'am, one doubt, ma'am. In the magnetron, two short questions are there, ma'am.
Magnetron, two short questions.
One
Total
is the
three.
principle of magnetron
And two voltage,
second-
Hall cutoff voltage. Voltages two kanukuntunnam kada. Hull cutoff magnetic field, Hull cutoff voltage equations.
Yes,
That's
ma'am.
a question. And in klystron we have short questions. Klystron లో వస్తుంది చూడండి. యూనిట్ ఏ యూనిట్ ఇది? యూనిట్ 10 లో ఉన్నాయి షార్ట్ క్వశ్చన్స్. ఎక్స్ప్రెషన్ ఫర్ వెలాసిటీ మాడ్యులేషన్, బంచింగ్ ప్రాసెస్ అండ్ ఎఫిషియన్సీ. 3 షార్ట్ క్వశ్చన్స్.
magnetron అనేది లాంగ్ క్వశ్చన్ వస్తుందా మేడం? బోత్ magnetron హాల్ కట్ ఆఫ్ మ్యాగ్నెటిక్ ఫీల్డ్ రెండు హాల్ కట్ ఆఫ్ మ్యాగ్నెటిక్ రెండు కలిపి ఇస్తారా మ్యామ్?
రెండు కలిపి ఒకటే ఇస్తే క్వశ్చన్.
Yes, ma'am.
If they ask for 10 marks, then we need to write magnetron from figure to voltage, cutoff voltage, na?
Cutoff voltages also you have to write.
Okay.
3 essay questions: klystron, traveling wave tube operation, and magnetron. 3 short in this. You will get 1 short: expression for velocity modulation, bunching process, and output power and efficiency.
Ma'am, in traveling microscope,
Traveling wave tube
లో మనము ఇంకొక డయాగ్రామ్ ఉంది కదా మేడం, హెలిక్స్ ట్రావెలింగ్ ట్యూబ్ యాజ్ షోన్ ఇన్ ద ఫిగర్. దాని పైన వరకు మాత్రమే రాయాలా మేడం ఎస్ఏ క్వశ్చన్ అడిగినా?
up to diagram. చూడండి స్లైడ్ కనిపిస్తుందా?
Yes, ma'am.
Any doubts?
Yes, ma'am. For the essay question, up to that we have to write. Okay, ma'am.
Next, bunching process. Five slides. For the positive voltage, what is the velocity, status of velocity?
Increase.
Increases. For negative voltage, velocity is
Decreases.
decreasing. Across the axis, velocities or across the drift space region, velocity is neutral, unchanged. Is it? Using
Yeah.
this diagram, I drawn another graph. See here. Across bunching center means across three different spaces I am taking. See here, center point. This center point I am taking as T of X. This negative end point, this point I am taking as T of Y. In the middle point I am taking as what? T of Z.
PZ.
I am taking one center point as L1. From here, I am drawing three lines, which is touching to X. Another line is touching to which one? Y.
Y.
Another line is touching to
Z.
Z. As it is longer across the T of X, the velocity is slower. Just observe the line.
Yes, ma'am.
Here, neutral. Next here, space is less. Minimum distance. This is minimum distance. This is maximum distance.
Maximum.
Maximum distance. Slower velocity, same velocity, faster velocity. The first one is slower velocity, distance is maximum. The last one is minimum distance. Using this, now I am calculating the equation for the length equation. I am calculating length equation L1. What is the L1 equation? L1 equal to V of E, velocity of the electron, V of E times of Tp minus Ty. This equation is across Ty. Ty point we have now, where we have, this is Tx point,
TY.
Ty point, this is Tz point, this is Tp. Across equation, length equation across Y is V times of Tp minus Tb. The same equations I am writing in terms of Tx and Tz.
Okay.
Same equations is written in terms of Tx and Tz. And this velocity, velocity of the electron I am taking as minimum velocity and maximum velocity. Just see the diagram. Slower velocity I wrote. Slower velocity means velocity is maximum or minimum, T of X.
Minimum.
If the distance is maximum, velocity is minimum. Distance
Yeah.
is maximum, velocity is minimum. Across X, we have minimum velocity. Across Z, we have maximum velocity. So I wrote three equations. One equation is related to Ty. Another equation is related to Tx. Another equation is related to Tz.
TZ.
And I'm considering Tx, another one. Tx equal to Ty minus pi by 2w. What is the value of if this I am getting from figure 1? What is figure 1? As per the velocities, this is the first figure, this is second figure. From the figure 1, I am treating Tx is equal to Ty times of pi minus 2w. What is Tz? Tz equal to Ty times of pi plus 2w. This Tx and Tz I am substituting in equation number 2 and 3. What is substitute equation number 2? Equation 2 lo substitute cheyalama idi ippudu. Tx in place of equation 2, you substitute Tx. What you will get?
L1 equals to V minimum.
L1
TP
equal
minus
to V minimum, Tp minus Tx value.
Ty.
Minus Tx we have, for that minus Ty, minus of minus plus pi by 2w. Substitute.
Ma'am, in the textbook it is different, ma'am. TP minus TY, TP minus TN, TP minus TZ, ma'am. Once
Tp minus Ty
That is
plus
not n, that is x only. T
In
x.
figure Ty is there, Tx is there, and Ty.
that is n ma. L1 equal to V
Ah.
minimum Tp minus in place of when you write x, that is.
Yes.
In the textbook, one sentence is written similarly for the electron at Tx and Tz. That is not n.
మినిమం కరెక్టే ఉంది కదా మేడం. టీపీ మైనస్ టీవై
n ఉంది చూడండి. Tp minus Tx అది n ఉంది మనకు టెక్స్ట్ బుక్ లో.
ఎన్ ఉందా?
10.12 ఈక్వేషన్.
అవును మేడం, ఎన్ ఉంది.
ఉంది కదా. Tp minus Ty, same way, two equations I substituted and we got equation number 4 and 5. And previous velocity calculations we did just now, velocity modulation with the discussed now. These two are velocity modulus equations, V minimum equation, V maximum equations. From the previous topic, what we discussed. Those two equations we substituted in place of Tx equation, Ty equation. What is L1? In this I substituted. What is L1? From equation 4, what is L1?
V minimum.
In place of V minimum, you substitute this one. In
Yeah,
equation
VE.
5, in place of V maximum, you substitute this one. These two you have to substitute. After substitution, multiplication, internal multiplication and common terms, you will get 7th equation. You just refer. If any doubt in the next class, I will tell, okay? I will send this one. I will send this one. V max and we are doing only for one, not for two at a time. Just I am checking for which one. V minimum one I am
V
calculating,
minimum.
not V maximum one. I am calculating only V minimum one. Step by step internal multiplication. See here, VE, TP term. VE 1 times of TP, VE TP, like everything is I multiplied and made common. We got equation number 7. After getting equation 7, substitute 6 in 5. 6 in 5 means for the maximum. This is equation for which one, minimum or maximum?
Minimum.
We calculated equation for minimum. Same way we have to calculate equation for maximum. Minimum equation is equation number 7. Maximum equation is equation number 8. After calculating 7 and 8, what I am doing? I am just taking only the second part. What is the second part, my here? This is first term of the equation. This is what?
Second term.
Term of the equation. From equation 7, I am calculating for minimum, not for maximum. For minimum, I am taking equation 7 and making second term to equal to 0. And after making TP minus TY term LHS, I got this equation. Just cross check. I got this equation. Which equation? TP minus TY. What got I got value? Pi by 2W times of 2V minus beta Vs minus 1. This one I am substituting in the next. Actually, I said second term is equal to 0. Is it?
Yes, ma'am.
Second term is equal to 0. In the first term, I am substituting this TP minus TB value. After substituting, this is the value of length. L1 for minimum I calculated. This is the equation for which one? Minimum or maximum?
Minimum.
This is minimum. Just I am giving one more. You will understand easily. Everything is given step by step. Again, just I am giving overview of this topic. And I will stop. What we are doing from the beginning, for the positive, voltage is positive. For the negative, voltage is 0. Across this point, voltage is 0. And I'm taking one point, central point, calling as bunching center. From bunching center, I'm drawing 3 equations. Slower velocity, same velocity, faster velocity. If it is slower velocity, distance is maximum. From this, the basic step is this one. 3 equations we had to write. We had to write 3 equations in terms of Ty, in terms of Tz. Another equation is for what? Tz equation, Tx equal to Ty equations. Next, we have to imagine Tx, Tz, substitute in that. You will get equation number 4 and 5. Substitute V minimum value and V maximum value. If you substitute V minimum value in equation 4, which equation you will get? you will get 7th equation. If you substitute 5th equation, maximum you will get equation number 8. After getting these three, what I am doing, I am concentrating only which term? Second term. From second term, simplification of second term. I got, which value I got? Edochindama value.
TP
From
ma-
second term. From second term, which I got?
V minimum.
No. From second term equating to 0, I got TP minus TY value. Which value I got?
TP minus
Minus
TY.
TY value. Again, I am saying that this second term is 0.
Okay.
Only we have first term. What is your first term?
Minimum.
L1 equal to VE plus TP plus TY. Another what we have? Ly equal to VE TP minus TY. In this, I am substituting TP minus TV value. What I got? I got L1 value. Whatever L1 value I got, that is calling as optimum bunching occurs across L1. What is this topic? This topic is about bunching process. So we completed 3 short questions. So what are the 3 short questions we completed? One is bunching process. Another one is expression of the velocity modulus. Another one is
Power and
output
efficiency.
power and efficiency. So complete block 5 is completed without skipping one topic, because why I covered is here we have 3 units. 3 units means you can expect 2 essay questions. 2 units means you can expect 1 essay question. Without skipping any topic, I completed complete microwave tubes block 5. So who are not attended offline classes, next classes I will cover block 1, block 2, block 3.
మేడం ఇది
Hmm.
పీడిఎఫ్ నిన్న సెండ్ చేసినా మేడం గ్రూప్ లో.
చేయలేదమ్మా, ఇప్పుడు పంపిస్తాను.
అదే నేను లేకుండే.
ఇప్పుడు బ్లాక్ 5 కంప్లీట్ గా అయిపోయింది వితౌట్ స్కిప్పింగ్ వన్ టాపిక్. ఇన్ ద
Okay.
నెక్స్ట్ సెషన్స్ ఐ విల్ కవర్ బ్లాక్ 1, బ్లాక్ 2, బ్లాక్ 3.
ఓకే మేడం, నోట్స్ ఉంటే కూడా సెండ్ చేయండి మేడం.
Ma'am, today's class also send the notes.
I will send my today's class notes. I will send. Okay.
It's
Class
very easy.
completed.
ఓకే మేడం.
Okay, ma'am. Thank you, ma'am.